customers. We're spread mostly in Jakarta, Pune, and of course in Singapore, and we have a sizable number of remote workers spread all across the world. And speaking of working, we are hiring. You can hit the job board on the link you see here, and feel free to speak to any of the DK folks after the talk. And we welcome talks from anyone, whether you're a student dipping your toes into ML Ops for the first time or data science, to a seasoned professional wrangling Jupyter notebooks all day long. However, we aim to keep the presentations approachable to a wide audience as much as possible. So just head to meetup.com and search for Machine Learning Operations and Data Science SG, and you'll find the link in the description below. Finally, if you attend meetups just for the stickers, then we've got you covered. Huge props to Cecilia, our designer, who has made everything pretty, from designing the meetup banner page to the stickers you see over here. I'll leave the stickers like somewhere over there at the end of the talk, so feel free to grab some. All right, end of commercial, and let's get on to the main show. So once again, welcome. Today I'll be talking about how we started to implement automated deployment over at DK, and how Bento ML is a core piece. The main takeaways are the following. Hopefully, I'll manage to convince you why Bento ML is awesome. And if you're convinced how you can implement automated model deployment with Bento ML, then I'll also provide a roadmap on how you can make Bento ML work for you for your own setup. But before that, let's take a moment and think about why model deployment is a hard problem to solve. Model deployment is often at the tail end of the machine learning pipeline. And it's often when the data scientists will start to hand over the model to the machine learning engineers. But from the machine learning engineer's point of view, there's a couple of things to consider. So for instance, we need to think about how the model was built, because that would also affect how the model is going to be served. And once you think about that, then you need to think about how the served model is going to be consumed. Are you going to wrap it around an API? Is it going to go through gRPC and things like that? Then once you've got that covered, you need to think about scaling your workloads. You know, if you have a relatively simple model that inference takes less than sub-second, that's fine. But you're thinking about image classification problems, then you need to think about how am I going to do proper batching? Do I need GPUs for my workloads and things like that? And once you have your model in production, then you need to think about monitoring and logging, because once you deploy a model, you know, things would go wrong. You get data drift, you get weird people trying to test different things on your models. So you need to constantly monitor and log your models in case something goes wrong, as it inevitably will. Then once you have your model in deployment, then you need to think about, okay, how am I going to deal with model retraining, right? Because once data drift happens, then what? So you need to come up with a strategy where you can continuously retrain your model with fresh data. And once you have that, you know, you're going to have multiple models, right? Then how are you going to maintain the multiple versions of the model you have in deployment? So for example, my boss wants like 17 versions of the model, right? How are you going to keep all of that in our heads? Exactly, right? And how to monitor them, how to log them, and things like that. So these are some of the problems that we have to consider once we get into the model deployment stage. Now, if you need more reasons why model deployment is hard, Tim Liu from the Bento guys just wrote a blog post a couple of days ago covering other reasons why model deployment is a really hard problem. For us, the main benefit of Bento ML is that it abstracts away a lot of the DevOps complexity. So, for example, as you see from the following slides, Bento ML provides things like commands to build a Docker image from the project that can easily serve the model. It provides things where a centralized UI where you are able to see all your deployed models. It comes with Swagger out of the box, as I will show you later on. It has cool things like monitoring and logging put in, right? Like, you know, both of us, the MLEs, don't wake up every day and it's like, oh my God, I'm so excited to implement Grafana and Prometheus metrics. And also, I think one of the most important points, as you'll see later, is that it provides a self-service platform for data scientists to deploy their models, right? So the data scientists won't need to bug the MLEs in order for them to deploy and test out their models. And before you ask, what kind of models does Bento ML support? Can I use Bento ML with my favorite machine learning framework? The answer most likely is going to be yes. So as you can see on the list over here, it supports like most of the major and popular frameworks. And if you have a new fancy artisanal ML framework that is not supported, you can relatively easily implement a custom runner on your own, and it's not really hard. So till now, everything might seem a bit abstract. And what I'm going to show you next is how the data scientists would typically interact with Bento ML. And as I go through the workflow, it might also help to imagine how you would integrate this with your own setup. So here's a pretty vanilla looking training code. We're loading the data set, splitting them up into the different training data. And then, of course, you just run model.fit, right? Which is exactly how everybody trains their machine learning models. Now, this model training code can live on, say, your Jupyter notebooks, but eventually you still want to automate this and make it part of your machine learning pipeline. But most of the code here is not important, except for the second last line. And what this line does is to save your model into the Bento ML local model store. And once the model saving here is successful, what you'll get is Bento ML would assign the model a tag. And you might be asking now, where exactly is the model saved? So what happens is that the local model store simply lives in the Bento ML directory in your home directory. Right? So as you can see here, if I do a tree Bento ML models, you can see that the model is saved over here. So now that you have your model parked in the Bento ML model store, the next step would be to create a prediction service. And if you're familiar with things like creating model inference services backed by Fast API, for example, the process is pretty similar. In Bento ML, the extra thing that you need to think about is to create a runner. And in Bento ML, a runner is a unit of computation that can be executed on a Python remote worker, and it scales independently. Now, you can do some interesting things with runners, like things like A/B testing and transformers. But for now, we're going to keep things relatively simple. So as you can see over here, once you have initialized the runner, the next step would be to pass the runner into the Bento ML service. So finally, once all that is done, you'll want to define a classified endpoint where the return result is the inference result that you get from calling predict.run from the runner. Now, if this is all slightly confusing to you now, don't worry, because there's lots of examples on the Bento ML side. And what's cool over here is Bento ML supplies a really handy command so that you can test out if your model service is really working. So if you were to follow the URL at the bottom here, you'll be greeted with Swagger UI, right? So I think a lot of you might have used Fast API to create your inference models. And one of the cool things about Fast API is that you get Swagger docs for free. And this is awesome because you can always send it to business and say, yo, here's the URL, go play with it, your heart's content, right? And if you squint a bit here, other than the predict endpoint, you see three other endpoints that are provided. So there's metrics, health Z, and life Z. Now, the data scientists will not be excited over this, right? They don't really care. As long as predict works, all is good. But the MLEs will be super happy with this because these endpoints will be used during deployments for Kubernetes, right? Kubernetes best practices dictate that you have all these three endpoints so that you get your metrics, you know that your service is up and running and live, so that your health probes and your liveness probes are all working fine. And most of the times when we are doing these, it's always like one of the last things that we do, right? Because this is not a sexy thing to do, implementing health Z and live Z. And having Bento ML think of this for you up front, I think is really cool. So what's even better is that if you see on the right-hand side, there's already a bunch of default metrics already provided, as you can see on the right-hand image. Of course, you're free to configure them on your own, but again, it's really nice for them to be set up from the get-go. So now we are at the part where we are starting to think about deployment. And to do that, you need to create a deployable artifact, right? Because at this point now, you just have code. You just have purely code, right? Nothing is being deployed on Kubernetes yet. Now, this artifact would be a file archive that would contain things like your source code, your models, your data files, dependency configuration required to run your service that you have defined earlier, all wrapped up in a standardized format. Now, this format happens to be called a bento, no surprise. Now, in order to build a bento, you have to run the bento build command from the project directory. So once again, just like in the models case, when you run Bento Ml build, you get a tag at the bottom. And just like saving models, you'll find that the bentos in the Bento Ml folder in your home directory. And now, this part is interesting because if you peek into this directory and you look at it, think about the stuff that you did not have to write, right? First of all, you got the Swagger definitions that are already generated for you. Now, if you use Fast API, I recall there's like a command where you have to generate this openapi.yaml file. Otherwise, the definitions will not be updated. So having this done automatically is really nice. The second thing that the Bento ML build command generates is a Docker file. Now, this is great because now the data scientist has one less thing to do, right? Because they don't have to think about writing the Docker file. It has already been automatically generated from them based on the requirements file that you have defined previously. Now, in fact, Bento ML comes with a really handy command to containerize your model service. Now, this is also good and awesome if you want to test out your Docker image on your own laptop. And finally, it even comes with a locus file so that you can do load testing. So let's briefly recap what we have gone through, in particular, what the actual workflow is. So first, you have your model training code. Right after that, you get your train model, and then you want to save that train model into the Bento model stock. After that, the next step would be to create a service.py file that represents the entry point to your model. Then you want to create the bento by running the Bento ML build command. Then at this point, again, you haven't deployed your model yet. And this is where the next piece called yatai comes in. So yatai means food cart in Japanese, and it seems like the Bento ML people are big on Japanese food metaphors. And if you look on what exactly this is, yatai is a production-first ML platform on Kubernetes, right? You can read the description, and as you will see later on, I think it pretty much sticks to what it promises here. So yatai can be installed via Helm chart. So you basically need Kubernetes to run yatai on. But in general, the process is quite straightforward. And the installation brings in a bunch of components like Postgres, a Docker registry, MinIO, which is a S3 compatible object store, and a bunch of other yatai related stuff. And the first time you access the UI, you'll be asked for an initial password. And this is how the main dashboard looks like. So on the left-hand side, you see menu entries for some of the things that we have already talked about, like things like models and bentos. The next thing on that list is deployments, which is a perfect segue to what we're going to cover next. So before you push your bento to yatai, you have to do a login. And during testing, of course, you can do this on your local machine, but eventually this step you'll want to be integrated into your CI. And I will show you how to do that later on. And once you've got that done, pushing the bento is as simple as running the Bento ML push command. And what this does is to upload that bento up to yatai. So we're at the stage now where we're still kind of doing manual deployment. As you can see in the next few slides, it's not complicated, and even data scientists can deploy their models without intervention from the MLEs. So this is how you do manual deployment. So remember we had to do bento push, right? So now once that's done, what Yatai does is it takes the bento and containerizes it. So the end stage would be you have a Docker container living inside the Docker registry. So once that's done, the data scientist would go to deployments and go create a deployment, right? And from this list, essentially what you're doing is A, you give the deployment a name, and B, you select the bento from a list of stuff that you have already pushed. So the top would be like the latest model version, and the bottom would be obviously the latest, right? So this gives you a chance to deploy any kind of version of model you want. So obviously most of the time you want to pick like the latest one. And if you look below, it's some Kubernetes related stuff. So it essentially tells you how many replicas do you want to set your model to. So by default, I think it's like min 2 and max 10. And this is cool because by default, it already has configurations to let you horizontally scale your services, right? But again, most of the time as a data scientist, you don't really care. So you just want to get your model deployed, see, okay, looks good. And then after that, you hand it over to the MLE. But what's cool is it provides you with sensible defaults that you can get up and running pretty quickly. So what's cool here is once you get the model deployed, it automatically provisions ingress for you, right? So what that means is each model would be assigned a unique URL. So this is exactly what you see here. So so if you have an ingress controller, you can, the left-hand side will be populated, and then you can click, and what it does is it brings you to the Swagger docs, like that. So up to this point, it's all super manual, right? You still need to go to the, you as a data scientist, you have to go and click create and do everything. That's all and good for things like, experimentation. But of course, the holy grail is how do we automate everything as much as possible? So here's a super fancy diagram of how everything fits together. Now, I'm pretty sure most of you won't have the same setup, right? But I think that's okay. In the next couple of slides, I'm going to walk you through what each piece does so you can have a general idea of how everything fits together, but more importantly, how you can swap out the components to adapt this to your own setup. So we begin with the model training pipeline, which every project should have. So here we are implementing the machine learning pipeline in Kubeflow. Now, for pedagogical purposes, short train model here does everything. So things like data downloading, data preparation, trains the model, everything. We don't do that in production. But once the model gets trained, right, we save it over up to MLflow. So we use MLflow to do things like tracking of experiments, registering your models. So it will also track things like, hyperparameters, what are your evaluation metrics, and so on. And once the model is trained and once we have registered the model in MLflow, MLflow will return a run ID, which essentially is a URI to your model. So this is like a unique identifier. Now, the key thing here is now we pass this unique identifier down to the next component, whose sole purpose is to trigger CI. So it's in the CI where all the interesting things happen, right? The first step in the CI executes a script that basically looks like this. So remember how we passed in the MLflow run ID, which is the unique identifier to the model that we have saved in the model registry. Now, in the trigger CI step, we get the run ID from the previous component to fetch the model from MLflow. So once we have that, we'll save the model to the Bento Ml model store. All right. So now it's important to note this time that the model store is located in the Docker volume running the CI job. So this is so that when we push the Bento later on, the model will be available in the local directory. Next, we run a couple of sanity tests over here by generating an example input that conforms to the shape of the model, of what the model expects. Then we load the model again, but this time, instead of loading from MLflow, we're loading it from the Bento ML store, Bento ML model store. And then when we run that again, we make sure that inference works. Otherwise, if things don't work over here, we want it to crash, right? We want to know if something bad happens. So this is exactly how it looks like in CI once this step executes. Did I step on something? One moment, technical problems. You should plug it in and plug it out again. Just plug it in. Perfect. Turning it on and off always works. Yeah, works every time. So once again, this is how it looks like in CI, right? So you see a bunch of numbers here, but this means that inference is working, so everything's awesome. So now that we have got our model into the Bento ML model store, we've also previously created a service PY that is really similar to how we would do it in Fast API. So now the next step would be to build the Bento, except instead of doing it on your laptop, we're going to do this in CI. And if nothing goes wrong, this is what you're going to see, right? So this would mean that the Bento has been successfully built. So remember, building a Bento means that you have a deployable artifact. Not yet deployed, but deployable. So now that we have this deployable artifact called the Bento, we want to push this Bento into your type, right? So this is exactly what is happening here. And while Yatai is working its magic, right? So it gets the Bento, it pushes it to Yatai, and then it starts all the containerization stuff. What we can do is the next step would be to prepare the deployment.yaml file. And this is usually where the MLEs will come in and you craft a very nice deployment.yaml file, and then you manually do a kubectl. But what we're doing here is we're using Unix magics to perform some string substitution on the deployment.yaml file. And if you think about it, this is exactly the same thing what's happening if you were to go into the UI, you create a deployment, you fill up the name, replicas, blah, blah. This is exactly the same YAML that is generated. So finally, all that's left to be done is to run kubectl from the CI, and then you wait a bit, everything will be done, right? Your model will be deployed. And again, same as before, once the model is deployed, you get ingress, you get monitoring, you get logging set up nicely. So for MLEs, this gives you warm and fuzzy feelings because Grafana works like the first time around with metrics. And this is Loki logs. I don't know if people know about this, but this is also super handy. And what this does is it tracks like things like event logs, and even when you get inferences, you get like the results all printed inside here. So it's worth coming back again to see how everything fits together, right? We have Kubeflow running ML pipelines, and this time a model is trained and then gets it saved into MLflow. MLflow returns a run ID, which is then passed to the downstream component, which sole purpose is to trigger your CI. And in CI, the script downloads the model from MLflow, runs a series of tests, and then runs some Bento ML commands that builds the Bento, pushes it up to Yatai, and kicks off the whole containerization process. And then in the meantime, you perform some Unix magic to do some string replacement to prepare the deployment YAML file, and then you run a kubectl, create deployment file to create the deployment, and then everything's awesome. So if if you look at this, like many of these components can be swapped out, right? Like you don't have to use Kubeflow to run your model training pipeline. You can use Airflow. God forbid you can use cron, but as long as you run something, it's automatable, it's totally fine. GitLab, you can swap it out also. You can use Jenkins, whatever. MLflow. Now, some people love MLflow, but again, you don't really need MLflow. You can even have something relatively simple like S3, right? Push your model out, have some unique identifier, return it, pass it to CI, CI downloads from S3, everything's the same. Of course, you can't swap out Bento Ml yet, but most of the other stuff you can swap out and then adapt it yourself. So hopefully you can see that all these components all can be swapped out, and you already have an idea on how you can kind of implement this on your own. So at least in our experience, like not everything was unicorn and rainbows, and part of the reason is GKE. So how many people is running GKE over here? Oh, perfect. So I hope Google's not listening, but no one's raising their hands. So what's interesting for us for GKE is that under the hood, remember how Bento does its containerization in Yatai, right? So this means that it's kind of running like Docker in Docker, right? In order to build the Docker images, it has to execute on Kubernetes. But what we ran into a couple of issues where the Docker images wouldn't execute successfully. And part of this is because it's using the Google's container optimized operating system, which doesn't allow for chmod plus X, which you need for the last step to chmod plus X your Docker entry point. So set vendor. So what we had to do was instead to provision an Ubuntu node pool instead. And once that's done, like everything was very nice. Everything worked. So this was exactly the problem. This is exactly the problem, right? If you look at the final step, you get an operation not permitted. So if you're running on GKE and on the container optimized operating system, this is what you're going to see. And on an Ubuntu node, everything works flawlessly. So the fix here was to implement a mutating webhook. So this is like a Kubernetes thing, and what a mutating webhook does is it intercepts. So for example, you do your create a pod. It intercepts the API call, and based on whatever logic you specify in the mutating webhook, it would change like certain components. So here the purpose of the mutating webhook is to see, as long as the pod is deployed on the Yatai builds, the namespace, add some nodes, tolerations, and taints so that it's being scheduled on the Ubuntu node pool. So building the mutating webhook is a relatively involved process, even though the logic is quite straightforward. Thankfully, there's this guy that's super helpful where he walks you through building the webhook like from start to finish. Again, this only affects GKE, sadly. So if you're on something else, then I guess you should be fine. So what about model retraining? When you start to think about model retraining, you need to think about at least 3 things. So first, you obviously need your model training pipeline because you need to automate your training in a repeatable and reproducible way. And once you have this, it's only a matter of scheduling it regularly, right? Depending on your machine learning problem, you probably just need to reschedule model training, say every week. You don't have to have any fancy logic that you need to build in to decide, oh, when should I do model retraining? So once you've got recurring runs done, the next thing is you need to figure out what kind of metrics do you need to decide which model is better, right? Because say you have a model in production now, and you have your newly trained model, how are you going to compare and decide when to flip the switch? And I think this, by and large, requires a bit of input from the data scientist to decide on the metrics. And finally, once you have metrics, you need to figure out a way to swap out the existing model and deploy that model. So this is kind of like the flow that I've imagined in my head. Right, so the model evaluation piece would sit between Bento ML and your CI pipeline, right? So once you have your trained model, you can go interrogate the Bento ML registry or the ML flow registry, download that model, and then you can perform comparisons there. And if the model performs better, then you can call out to Bento ML to deploy the model. But for the piece on top, how the mechanics to swap out your running model for the new one, that one I'm still thinking about, right? And one approach could be simply to change the pointer of the service inside your ingress. So if you have your ingress, like, say production model.blah.blah.com, the way that ingress is implemented is, if you look inside the manifest, it's usually a service, right? So you could always update the service pointing to the ingress. And since in Bento ML, each model would have a unique identifier for your service, right? So you can have like model version 1, model version 2, and you can just update it again in CI, and then everything will be nice. Of course, you would have to put in your monitoring and logging to make sure that nothing goes wrong. So how can you get started with Bento ML? I think the easiest way would be just to pick an existing project and then slowly try to convert. If you see over here, Bento ML isn't that intrusive, right? It's one line to save your model into the model registry, and most of the other steps are all baked into CI. Yatai can be installed on Minikube, so in case you don't want to run or rather to install it on your Kubernetes clusters, you can always run it on your own laptop. The Bento ML guys on Slack, they're super responsive. So, hop on there, ask questions, they'll reply you like super quickly. And finally, one really helpful thing that I used when I was learning Bento ML is the Bento ML gallery. And what it has is a lot of examples and use cases. So for different frameworks and different problems. So if you have an image classification problem, or you have like a fraud problem, more likely you're going to find some examples on the Bento ML gallery. So I have to plug my company's blog. So go to the site. We've written a couple of stuff that we are working on. And yeah, it's regularly updated with new things that we are working on. So there you have it. I think overall, I'm quite pleased with the setup, primarily because you get automated model deployments. And I can also kind of imagine how it would be relatively easy to generalize this across to other projects with minimal setup. And if you think about it, Bento ML really does get you pretty far with respect to model deployment. We wanted to tackle this exact problem by writing something similar, but of course it will be half-baked, error-prone, and a bug-ridden implementation. So I'm glad the Bento ML people have figured most of these things out. So cool. Do you have any questions? Thank you very much.
I think I saw a part of the interview as well. But I mean, of course, working with only a model itself is one aspect. Basically, changing the behavior.
Right. So the question is, now that you have like this automated model deployment, how are you going to deal with things like data drift? Right. Good question. So for that, I point you to the first meetup session that Varun did, which was exactly the thing that he covered. But to go back to your question, right? Again, if you take a look at the diagram, you can imagine that you're going to bolt on additional things like data drift component. You can either do it here when you're training or retraining your model, or you could have data drift like live, right? You can have it constantly running and checking. So it kind of doesn't matter how you implement it. Again, depends on the kind of problem. But you could implement it data drift even out of this, right? You don't have to have model deployment for this. The way we have done data drift detection for now, for the batch case at least, would be just plug it in one of the components over there. So for that, I think it's relatively straightforward.
Back to the effort, how are you training that training work?
Right. So the question is, we have Kubeflow pipelines running, but where is the training workload performed on?
Yeah.
Right. So we run all our workloads on Kubernetes. So Kubeflow runs on Kubernetes. So everything runs in pods, services, deployments, things like that.
How do you keep training?
Right. So that would be a future talk, but in general, there are a couple of ways that we feed our training data in. One of the core components that we use in DK is the feature store called fees, right? And what this does is, it provides a store for all your features. And then, we'll query them, and it's backed by BigQuery. So BigQuery is one of the core pieces that we are using in our company.
So it's like the training during training process data goes through from the source data.
Exactly. Yes.
Does your machine learning job is like structured data or image?
So thankfully, most of the ML problems that we have is structured data, right? So it's not super heavy. You're not going to put terabytes of images and things like that.
And that's training part. Serving part. So on top of the chart over there, you're saying like the changing pointer of your finger or service one two. But in most cases, it's like you'd be like splitting the traffic instead of the whole loops, right? How do you guys do that?
Right. So that's a very good question, and I left that out in the slides. So remember how I mentioned that in Bento ML there's the concept of a runner, right, which represents like a computation. Now, let me see if I can bring you back to the code. Here we go, this one. So the question is, how do I implement A/B testing? Cool. So imagine instead of Iris CLF runner, this is model version 1, right? And imagine I duplicate this line and I call it model version 2. Now, what I can do is, for runners here, I can pass in two different two lists, right? So model version 1, comma model version 2. Cool. So in classify, I can call model version 1 dot predict dot run and call model version 2 dot predict dot run.
How do you decide?
Right. So there are a couple of ways to do this. So for me, I like to keep things relatively simple, right? So in this case, you can do like really A/B testing. But if you want to do fancier traffic, I will use something like Istio to control that kind of thing. So I haven't really and because Istio does traffic splitting, right? So you could always use that, because I think that's more like a network layer concern rather than a machine learning problem. So I would delegate it to that way. It's half, but I agree it's a bit iffy, but I will use Istio for this.
Gotcha. And another question on top of that would be whether the like starting to reach out and really
So thankfully, we haven't had to use GPUs yet. So we try to squeeze out as much performance from our CPUs as much as possible. But ever we need to use GPUs, then yeah, BentoML can still handle GPU workloads, no problem. Yeah.
like it, but it's important. But there's
I'll repeat the question.
mistake I have for questions. If some of your models require to take a result, which are okay. Well, Bento will often be a store except binary key like. I mean, what I want is that sometimes we want to new data set, let's say a trade, multi-stage, right?
Hmm.
And then I want to tweak parameter in step 3, and next time I want 4 and 5.
Right.
So I
So
want to use the maybe the steps of data. Is that
right. So your question is, what if inference happens in multiple steps, right? And each step is dependent on some other step. And how would Bento be able to handle that relatively intelligently? Now, again, yes. So I can send you a link because I was showing Varun just this exact example. And the way this is done is again through runners. So each of the runner would represent a piece of the computation. And once that's done, you can use concurrency primitives to compose the computation.
maybe direct question?
Yes.
Are you using DBC for this?
So we use DVC for model training in the model pipeline, so not during inference.
You can have it now. Of course, I know what Bento.
I mean, we all know it, right? The status aspect is it for a because this is a I also gain this up to handle data six. Then I tweak some parameters. I don't want to recommend.
I feel your pain. So your question is, how do I automatically determine which model is the best, right? And I think, again, for this, it depends on the data scientist to come up with the best evaluation metrics so that we can quantitatively say this model is better than the other. Now, I think it's still an iterative process, right? Because I wouldn't trust the data scientist to come up with version 1 of the evaluation metrics and say, ship it, it would be awesome. But again, you can take something intermediate, right? You can, connect something to like Slack where it would post the results of the retraining of, say, model 1 results, model 2 results, and then you can kind of eyeball it and then test it on your own, right? And I wouldn't, besides even evaluation metrics, I would come up with, additional steps like coming out with like a regression test data set, right? Like a data set that's not huge, but with test cases where the model definitely has to pass, right? If it fails any of the 10 test cases, if it fails any one, it's a showstopper, then it fails. So I think there are ways to bolt on things like that, but again, I don't think there's a very straightforward solution to that. You still need the human in the loop to figure out what is the best metrics, and then curate a bunch of good test cases in order to determine, okay, this model is like better than the other one. Right. So again, so the question is now that, yes, you have metrics for your model deployment and everything, but then you still need to come back to the problem of, oh, what about data drift, right? What if I have fresh data? What happens to my model? Which is why exactly like you mentioned, you need to have your data drift detection going on. And not only that, again, machine learning problems is code and data, right? So data is, I argue, like more important than your code. So you need to figure out a way to get fresh data into your model's retraining as soon as possible. And even that part can be automated, right? So once you have that pipelines going on, then obviously you have the whole, you can start from data, get fresh data, put it into your model, retrain it with fresh data all the time. And from there, see the metrics, right? And again, from there, then you can check whether you have drift detection all over again, right? So I think that is a relatively good feedback loop that we can kind of implement in an automated way, but it takes work. Mhm. Right.
So how does it
So Yatai provides so the way it implements it is through a horizontal port autoscaler. So I think it's smart enough to see how many requests it's coming in, and if the load for a certain port is too high, then it will automatically spin up a new one.
what if like the controller I know it's like service I was imagining like if it's AT&T they're all getting money.
Right. So I think that logic, that scheduling logic is baked into the horizontal port autoscaler. So I think it's a Kubernetes thing.
That's why I'm
Yeah, I mean, there will be HPA for every single service as such.
Hmm.
So every service is independent of each other.
which means I would not be following the quota on any other service.
Yeah, no, it's on its own.
Yeah, every one is independent. So the only thing that's limiting is probably your Kubernetes resolver itself, or the node itself. And that also can be overcome by just sending a node to autoscale to service.
Okay, so that sounds like the second that you have a stat cell. And
Yes.
and every service is like, hey, I'm getting like request coming in and times. And what's going to be happening is like we'll be having a lot of over practice with Kubernetes clusters. Is that what you guys are doing?
Hopefully, we have alerts before we reach that stage.
Oh my god.
Yeah, I mean, if ever such a high load comes, then obviously, I mean, if it's unexpected, then obviously, I mean, something else may be happening on the phone. But if it's, I mean, this just comes down to how well we load test our applications before and how far load are we expecting. So, yeah, that's, I mean, all that is, yeah, I mean, like mentioned, there are locust files generated for the services. So one would expect us to use that, would do some sort of a load testing beforehand. But yeah, I mean, every application has a built-in term, it's just knowing what it is.
Okay. It's about self-healing.
Sorry? So the question is, does it support self-healing? So in general, it's more like a Kubernetes concern, right? So your pods can go down, but it would always spin it up if it's backed by a deployment. Now the problem is it can get stuck in a loop also, right? It crash, it brings it up, it crash, it brings it up. So I wouldn't really call that self-healing also. So that's why it's important again to have like monitoring and your logging baked in. But yeah, I've seen it when the thing crashes, it brings it back up. So yes. But again, that's like usually a Kubernetes thing. I haven't seen it. Cool. All right. Thank you for joining us. Have an awesome evening. For the remote people that are joining us, thank you very much for joining us also. See you guys next time.
There's one question.
Oh, there's a question? Okay.
So you mean, yeah, the question was from so you're using the question was, so you are only using Google Cloud in the company, which is
Yes, we're just using Google Cloud. We are not multi-cloud yet.
what about data augmentation and computer vision for Bento? Can we use it for, I think, solving computer vision problem?
So Bento Ml supports any kind of models you can throw at it. So image classification, image detection models would perfectly fit into this.
And the one more question was, can I use Hydra libraries? Hydra libraries for parameter tuning using 2 separate models.
I have no idea what Hydra is.
So what?
Ah.
Yeah, it's
Cool. Yeah. But you can take your question to Bento Slack and I'm sure somebody will give you an answer.